Hello friends, welcome to the Boolean Brain in continuation to the LeetCode Daily Challenge series where we are solving the daily challenge from LeetCode. Let us try to solve today's challenge. The title says minimum time visiting all points. So on a 2D plane there are n points with integer coordinates points I, xi, yi. Return the minimum time in seconds to visit all the points in order. So we have to visit points in order. You can move according to these rules in 1 second. You can either move vertically by 1 unit, move horizontally by 1 unit, or move diagonally by 1 unit. You have to visit points in the same order as they appear in the array. Okay, the order is essential. So you are allowed to pass through points that appear in later in order, but these do not count as visits. Okay, so it again justifies this statement that the order is important. Okay, so let us try to understand this with this example. So we have given 3 points. Point 11 is here, point 34 is this point, and -1 is here. So we have to first move from 11 to 34. 11 to 34. The shortest distance is first try to climb as much diagonal as you can, because in diagonal you are traversing the horizontal as well as vertical by one. Right, so try to move as much diagonal as you can. So once you reach here, you just need to go 1 point here. So that's how you reach to this point. Okay, so this is the shortest distance, which is 3 seconds. Now from this point you have to go to this point again. Try to come diagonally as much as possible, and fortunately we received till the point here. So the total distance is 1 2 3 4. So 3 plus 4 is nothing but 7. So this is a very simple problem wherein it's just a ad hoc implementation problem where we have to understand the problem statement and try to add the basic logic and come up with the implementation solution. Now, one thing is clear that we need to first move diagonally. So in order to move diagonally, I need to find how many rows and columns I need to uh, climb. For example, let us try to understand with this. So I have these 2 points, point 11 and 34. If you carefully observe how many columns I need to move in between 1 and 34, this 1, 2. So 3 minus 1, which is equals to 2 columns. And in order to find the rows, this jth column indicates the row. So if you carefully observe, I am at 1, I need to go till 4. So 4 minus 1 is nothing but, sorry, this is 2, 3 minus 1 is 2, and 4 minus 1 is 3 rows. So if you carefully see, I need to climb 2 columns and 3 rows. This is my simple solution. Now, the problem statement says we can move diagonally. In diagonally, we can climb 1 column and row in the same time. So if I subtract the minimum of these two, why minimum? Minimum of 2 comma 3 is nothing but diagonal, which is equals to 2. So I simply need to subtract 2 columns minus 2, which is 0, and 3 rows minus 3, which is 1. So our answer should be the diagonal plus the left columns and left rows, which is nothing but 1. Answer is 2 plus 1 is 3. So 1, 2, 3, isn't it? So this is a very simple solution, ad hoc implementation of this problem. Let us try to quickly code this up. We need to iterate on all the points till the last point. So let me add a loop starting from 0. I is less than points dot size minus 1. Why minus 1? Because I need to find the minimum. I only need to move till this so that I will find the distance between these two. Okay, and increment the I pointer. Now I need to find out how many rows and how many columns I need to move. So if you carefully observe in this condition, so this is nothing but, this is 1 point ith and this is I plus 1 point. In order to find the columns, what we did, we subtracted we subtracted the difference. She subtracted the zeroth element. So subtracted zeroth element is nothing but I plus 1 of 0 minus points of I current points zeroth position. Can I do that? Yes. Now for the columns. So so this is sorry. This is columns and this is now rows because my zeroth position is demonstrating the column. Now in order to find the rows, I need to check I need to check the second element. Okay, in order to obtain the second element, I simply need to increment this change this position. So I have these columns and rows, but if you carefully observe, this also mentions about negative indexes. So I simply need to take the absolute value. Okay. Now my problem statement reduces. I need to move this much columns and this much rows. So what are the other steps? First, we find the diagonal. Diagonal is nothing but minimum. So int diagonal moves equals to minimum of columns and rows, isn't it? Now I need to declare a final answer, which I will return. Okay. Now I'll say, can I add this to my answer? Yes. So this is my part of my answer. What are the next steps? The next is how many columns were there minus the common. If there are some any more, if we reach till this, I need to find this, isn't it? So that will come by subtracting the total diagonal moves from the total columns. Similarly, I also need to update this for rows because I'm taking the minimum either of this or this is going to come zero definitely, but I'm not sure which one. So I'll just make it for both places. Now let me quickly run this up. Yes, sample are passing. Let's quickly submit this. Meanwhile, let us talk about time and space complexity. And yes, as you can see, we have successfully completed today's problem statement and it beats 100%. It means it's the fastest solution. So if you carefully observe, we are just running one loop, isn't it? So time complexity becomes O of n. What about space? Are we using any extra space? No, we are not. So it becomes O of 1. Okay. So this is our space complexity and time complexity. And this is a simple and faster solution available for this problem. I hope the problem statement solution approach, everything is clear to you. If you have any doubts or queries, please do let me know in the comments and please like the video and share it. Thank you.